Alright guys, so welcome to today's video, and in today's video I would like to start with the recreation of some of our magma moves. So I have created a Magu no Mi, yeah, some years ago, alright, probably 3 years or so. So back then I didn't even use my own voice to record all of these videos, and I've used text, or yeah, just text, which I blended in, barely explaining anything, you know. So in today's video, I would like to create a newer version of this food first of all, because the moves back then, they are shit from today's perspective, alright? But apart from that, I would like to explain all of the stuff I'm working on as well. And what I've not understood, but well, yes, somehow understood as well, is that the way on how I create the moves currently is not good, alright? So I'm not really satisfied with my work lately. And if I take a look at other people's work, for example, so if I take a look at GPO, Rampage Online, or Arclight Studio, so shoutouts to both of them. They are they have very good developers, okay? So my moves are nothing compared to theirs, alright? So their VFX is amazing. I would like to, you know, improve myself till I reach that point as well. And we're now going to try to create our own magma texture right here, which we are then going to use for our attack. And our attack is just going to be a normal magma fist. So basically our character's charging the fist, where the fist just turns into magma. Magma drops out of it, so you have some drops as well. And then the fist is just being punched forward, and with that action, yeah, the magma ball is being released, which leaps forward as well, and then hits the ground, so all of that stuff. And yeah, I'm going to be using some interesting stuff in today's video, so make sure to watch it. Alright, with that being said, let's begin with creating this image right here. I'm not going to be explaining anything in Paint.net, alright? So I expect you to know about this. If not, then check out videos about this, okay? I haven't made any videos on Paint.net, so no tutorials or such. You have to check them out from other people, alright? Okay, so I'm gonna begin this whole thing now. I'm gonna mute myself and I'm gonna speed the video up. At least I think so. And you'll just see how I'm doing those things, but I'm not gonna explain it, alright? So, let's see each other once I'm done. Alright, so we're back in Roblox Studio. Yeah, what I did not mention or show is how I've saved all of that stuff. So what you have to do is that you have to go to the top left corner and then save as and save as a PNG file, right? So that's very important. Now let's try to import this one right here. I'm going to be creating a part. I'm going to create a particle limit instead of here. Wait, where's the part? Okay, it's here. So let me create a particle limit. Let me actually create two. So first one is right here. And the second one is going to be called drops. And just for now, we're going to make sure that it is not enabled. Now we cannot even do that. How funny is that? Alright, then do the emission direction to the bottom, and we'll just deal with this one later. So let's import our image by going to texture and then wait, I have to move this up. So add image right here. I'm gonna add the image. I'm gonna pause the video and come back when I've edited. Okay, so here we go. This is our texture right here. So let's go to these drops. Actually, let's put it right here. Alright, so what we're going to do first is that we are going to shrink this down, okay? So let's shrink the drops down. And let's... wait. Let's take this one. Let's make sure that the speed is at 0. And that the rate... I don't know. I don't know about the rate. Now let's actually go to the size right here. Yeah. I don't know right here whether this is fun or not. Okay. I think that this is actually fun. Let's really try to, yeah, work on those drops right here. Let's first of all decrease the rate, because that's obviously too much. Let's try to work on this one. Actually, All right. Let's actually keep this at 0. So it's really about designing those particles, you know. So the more the more time you spend on designing this, the better the result will be at the end. I think that the fire right here, so this glowing right here is too strong in my opinion. We have to somehow reduce this. Let's actually use it this way. So let's just keep it like this. Let me take those drops and let me do the same for them right here. Now the problem with this one is that we cannot do the same. Cannot do we cannot do it. All right. So this is our fist right here. Those are our particles. Wait, so what happens when I put... Nah, it doesn't work. Okay, so those are our 3 particles, which have to be used. Okay, so what happens when I create ball, for example, okay? And I decide to put all of these 3 inside of here. Now, ball is going to be transparent. Okay. So I'm gonna prepare this ball right here, which is going to be fired later on. All right. So this one is going to be the product of our fist, you know, which we use to create the attack. Problem is that we still have to change the particles so that they fit to this thing right here. Okay, that's a good start. Let's see what happens with this one. Yeah, there we go. There we go. There we go. Wait. Maybe we should increase the speed of those drops because they barely reach the ground, you know? Let's increase the rate as well. Okay, there we go. There we go, there we go. Very good. So, I've now prepared the fist and this attack right here. Magu Fist Attack. So I'm gonna call this one Magu Fist Attack. Make sure that it is anchored. That's very important. And make sure that can't collide as false. Alright. Now move this one inside of the replicated storage. I'm still not sure about this one, so I don't know whether I should just take this part, clone it, and then weld it into our arm, or whether I should just copy all of these inside of each arm, you know, so left upper arm, left hand, left lower arm. I think I'm gonna do the second option I've just mentioned because it would look very awful if you would just weld one part to one arm mesh, you know. So what about the other arm meshes? So when they, for example, move, those particles they would not fit into the the other arm. So that would be one possible problem. You know? So let's move on with scripting this whole thing. So Magu Fist. That's the name of our attack right here. I'm gonna put a local script inside of here. Let's call this one client. And I'm also going to create a remote event. I'm just gonna call this one remote. Then I'm gonna create a script. Let's call this one server, alright? So instead of this client script, all you have to do is we have to refer to this tool, alright? So one more thing you have to do is that you disable requires handle. Otherwise, you won't be able to use this tool, okay? So inside of this client script, we are going to refer to the tool. So script is the client script itself, dot parent, and then activated. So activated represents the case when you have equipped the tool and when you have performed the left mouse button on it. Now, when you want to add some kind of cooldown to it, you can add a variable, which is going to be false at the beginning. And every time when this activated event is being triggered, you just check whether cooldown is false. And if that is the case, you want to turn it to true. And then you want to wait the amount of seconds you would like to wait in between each attack. And then cooldown equals false, you know? So wait 2 represents your cooldown time. So every 2 seconds, you're able to do this Magu Fist. You can change this if you want to. It is up to you. Now, next thing which we're going to do is that we are going to refer to this remote right here. So script, remote, Pia server. And yeah, that's actually it. There's nothing else you should do. Now let's go inside of this server script right here. And let's refer to this remote. So script, parent, remote, on server event, connect function, and player. All right, let me explain this to you. So script, parent, remote refers to the remote event. All right. Now on server event is an event of this remote event right here, which happens when this remote event has been fire servered. All right. So basically this one. And player is an argument which we receive via each fire server. So we are not adding the player inside of those brackets, as you guys might have seen it in some of my videos. This player argument right is automatically being passed with each file server, so there is no need to manually add it inside of here, okay? Now, what we want to do is that we want to refer to the character of this player, so player.character. Next thing which we would like to do is that we would like to make an animation play. And let's actually deal with this one. So let's put an animation inside of here. Let's create this animation quickly. Yeah, so let's create a new one right here. Magu Fist. There we go. Okay, so this is our animation right here. It is nothing too special, but I think that this is enough actually. So in order to, you know, just prepare against this one glitch. You guys might have seen one of my videos. So that glitch is that when you're playing some kind of animation, that the parts which you have not even touched via animator, that they just begin to wobble around, you know. So in order to prevent this, just select those parts. So probably our hands right here, so they are very, very often affected by this. All right. So just rotate them once and then rotate them back, and this should fix it. So make sure that the animation priority is set to movement, and then publish it to Roblox. Magu fist, submit. Let's copy the ID and then close. Right, add the animation ID inside of this animation right here. Now, I'm going to be referring to an instance inside of our character. So C, the humanoid dot animator. So this animator instance right here, it sits inside of the humanoid, and it is responsible to load our animations. All right, and we are going to load this animation right here, which is our Magu fist animation. So script animation. So you basically have to refer to the animation set of those brackets, and then you can make L play. All right, then the animation plays. But before we play the animation, we also want to make sure that our character is not able to move. So you have to refer to the humanoid of our character, and then to, first of all, the walk speed, but also to the jump power. So make sure that both are at 0. Okay. Now after that, we have to copy those particles inside of the arm. So we should loop through our character, and then we should check whether the name of the instance we're currently at is either left upper arm, now right upper arm, because we have animated the right arm, right upper arm, or v.name is right lower arm. Come on. Or v.name is right hand. Now, those are the 3 arm parts which form the right arm, you know? And we want all of those particles to be inside of the right arm. Means we have to put each particle inside of each arm part. So, if we have encountered any of those arm parts within this loop, then we want to clone all of those particles inside of there. So drops, game, get service, replicated storage, drops, clone. Actually, we should not put this inside of a variable, but we can just clone it and then parent it inside of B. And we can do this step for all of the other particles right here as well. So magma and magma fire. All right, let's play this and let's see how this looks like. We also should make sure that the transparency of each arm part is then set to 1, because I don't really like the look of having our arm inside of all of those particles right here, you know? And I also think that we should wait a little until we play the animation, because otherwise the player cannot really see the full beauty of those particles. So let's actually wait 0.5 seconds and then play the animation. Now maybe not even 0.5 seconds, but maybe even 1.5 seconds. So let's even increase this. Wait, let's test this out again. Alright, so let's try to work with this one, okay? So, what we're now going to do is actually very interesting, because I haven't really done this yet, alright? And I had to look it up myself and watch some videos about it. So shoutouts to Red Place. So he's another tutorial YouTuber on Roblox. Shoutouts to you, bro. I really like your videos, and especially this one about Bezier curves right here. So how to implement them and how to use them for moves right here, okay? So we're going to make use of his way on Bezier curves, okay? And you might ask, okay, so what is this about? So what are those Bezier curves and how can you use them? And I'm going to demonstrate this to you now, alright? So what we're now going to do is that I'm going to implement this, and I'm going to try it as good as I'm going to try to explain it as good as possible, but I'm still a total noob on this, alright? So if you really want to know how to do this, okay, and how to understand it, then make sure to check out Red Place video. So he spelled Red, E-L-Y-S. Check him out on YouTube, and especially the video about Bezier curves, and you should understand it then as well, alright? Okay, so we're now going to add two functions, alright? And those functions, they're going to be responsible to animate this Magu fist attack right here. But let's actually clone this Magu fist attack first of all. So X game get service replicated storage. So we're referring to this replicated storage where this whole thing is located. And then Magu fist attack. Let's clone this one. Let's position it in front of our player. So X C-frame equals character humanoid root part C-frame multiplied with C-frame.new, and then -5 on the Z-axis. Let's see what this whole thing is then. So where it is located. Okay. Now we forgot to parent this. Yeah, we did. We did forget to parent this whole thing. So parent it through the workspace. That's important. Yeah, there it is. Okay. Let's increase this to 10 maybe. Now, here is the interesting part, alright? So what this Bezier curve thing is able to do is that we're now able to define some points, alright? So some starting points, some goal points, and a middle point, alright? So start is obviously at the position of our current Magu fist attack, which is our humanoid root part C-frame multiplied with another C-frame, which makes this fist attack go 10 studs in front. Now the goal is going to be our humanoid root parts C-frame multiplied with another C-frame, and this C-frame is not going to be 10 because 10 is our starting point, but probably something around 60, alright? And make sure that you put this position at the end, so this one. Otherwise, this right here is only a C-frame, and we have to turn this into a vector 3, and you do this by adding this point position to it. Now we have to define a point which is going to be in the middle, all right? So the middle of this trail, let's say, all right? So from start to goal. And this one is going to be our goal minus our start, so the difference, plus a vector which is going to define the height, all right? And this is important. So the higher this middle point is, the higher this Magu Fist attack is going to fly and then drop down. Okay, so I'm going to demonstrate to you this later on as well. But let's just try to finish this, okay? Now, we have now set all of these points, okay? What we're now going to do, so I've already told you, is that we're now going to define some functions. So first one is going to be called lerp. And we will need 3 arguments, okay? And we are going to create a calculation right here, and we're going to return it right away. Okay, and this calculation is going to be a plus b minus a multiplied with c. Okay? Now, as I've told you, I'm still a noob on this. I only know that this and the function we're now going to create, they both in combination, they do all of the math behind this mechanic, alright? That's the only thing I know currently. I don't know why this calculation works, but as I've told you, I'm still a noob on this, alright? But I just wanted to share it to you because the fact that I still don't know everything about it should not keep you from learning about it as well, alright? So, we're now going to create this function, which requires t, start, middle, and goal. So those 3 are already defined down here. We just have to enter them. And t is going to be, is going to be a variable which we are later going to add. But I'm going to explain this later on. So what we need now are 3 more variables right here. First one is L1. So lerp. So L1 is going to be lerp, start, middle, t. So the line from the start to the middle point, and then this t right here. This t is important. So as far as I've understood it, it is some kind of time, alright? But I might be wrong as well. Second one is going to be from middle to goal, so that we have the line from start to middle, and then from the middle to the goal. And the third one is going to be called quad. And we're now going to lerp L1, L2, which make up the whole this whole line from start to the goal, and also the middle included, and then t. And then we are going to return quad, and that's it. Okay. So as I've told you, check out Redply's video on this because I still have to understand this better. All right. I only know that these both in combination that they create this what I'm just going to create now, but I still don't really understand all of those calculations, but I hopefully will later on. Now, next thing which we're going to do is that we are going to create a loop right here. So from 1 to 100, and then add weight to it, and then x c frame. So basically our Magu Fist attack c frame. It's going to be c frame the new, and now quad. So this quad function, and the first variable is going to be t. All right, so this time I was talking about, and let me tell you why I think that this has to do with the time, or at least with the speed of how long this whole process takes. So let's just add I. All right, I is basically the amount of loops which have passed. So I at the beginning is of course 1, then becomes 2, 3, and this goes up until it reaches 100. Alright, let me just have I right here, and I'm going to show you why I think so. So why I think that this has to do with the speed. Second one is going to be our start variable. Next one is going to be middle, and the other one is going to be goal. Alright. So let's play this and let's see why I is some kind of time unit right here. Okay, look. Does this thing still exist? Yeah, it does. But probably because of I being... Yeah. Okay. Yeah. I actually have to divide this already, so that I can show you this better. Nah, it still doesn't work as expected, right? Let's actually, instead of having X that position, let's actually add this one. Nah, nah, nah. Look, so as you can see, what happens is that the part right here has some kind of curving, alright? So it goes from right here to right here and then right here. But obviously, we do not want it to go this way, but rather this way, okay? And that's the reason why we still have to work on some stuff right here. What happens when I change it like this? Because obviously the y-axis wasn't really the y-axis we know. Nah, wait, it still does this weird stuff. Nah, come on. Alright, look, I'm gonna pause the video at this point and I'm gonna be back when I have found a fix for this. Alright, so while trying to find out what the problem was, I've done the following. So this emphasizes what this Bezier curve is capable of. So, as you can see, we have two parts right here. The third part should be right here, okay? But I did not create it because it is pretty obvious. So, the starting point is right here. Our middle is right here. And the goal is right here, okay? And when we now do this attack, as you can see, this ball right here, this Magu fist attack, strives to hit this one and then falls towards this direction, okay? And the way on how you position your middle part determines the flying angle, alright? So the way on how your Magu fist attack right here is going to fly. And this is basically what Bezier curves are capable of, okay? So it is actually a very cool thing. So when I, for example, lower this now, the angle changes as well, you know? Alright. So what have I done? I've just changed the way and how we approach the middle. Because the middle was not really the middle, but it was somewhere else, okay? So I've just subtracted 110. Then I had 90. Then 90 divided by 2 is 45. Then I have added 10 to that 45. Then I've you know, just came to 55. That's basically what I've done. Tell that, alright, the middle is somewhere there. I could even increase this when I want to, so maybe to 80, and then you'll see how the flight just changes, okay? So instead of dropping at the middle, it now drops right before the goal, okay? This is actually interesting as well. So you can play around with this. It offers so many cool opportunities right here. Okay, let me keep it as this now. And let me test this for one last time. Okay. There we go. So let's delete both of them here. And let's continue. So what is now going to happen? So I now want to hire server this remote event right here. So script parent remote. Now I want to fire client it. I'm sorry. And this fire client right here is going to lead to a camera shake later on, but we're going to create this later. So what are we now going to do? So when this part right here touches something, so axe touched, connect, function, hit. If hit is a part, or come on, or hit is a mesh part, then print hit magma explode. Okay, then we are going to do. It didn't work out right here. What happens when we place this inside of the loop? Does it work then? Yo, come on, you're literally wasting time. Come on. Yo. My God. Wait, let me publish this to Roblox. Disconnected. Disconnected. Look at it. Look at it. I'm gonna pause the video. I'm gonna be back. Alright. Come on, let's play this. That still doesn't really recognize something. No, but that's actually impossible because it is supposed to recognize. Alright, look, then we have to do it this way. Print X position. Wait, I would like to check out something. Yeah, it does work. Alright, it does work. So, if X position Y is not greater or equals C humanoid root part position Y, then print resolve. So since this Magu variety is unable to detect whether it has touched something or not, we are going to use this method, okay? So can I do break to break out of this for I loop? I hope that this does work. If not, then we'll have a problem. It did work, my friend. It did work. Very good, very good. Very good. Look. Okay. So, I also would like to test out something more. Let me add a point light right here. Oh, very cool. So Roblox has added some interesting visuals right here. Okay, cool. Let's put this one inside of this Magu fist attack. Let's see what happens. Wait, are we able to put point lights instead of particles? Does that work? Ah, it does not. Okay, so next thing which we have to do is that we have to create all of those, you know, shockwaves, etc., etc. So what kind of shockwaves do we really need for this one? So we first of all need some kind of shockwaves which just expand, you know, so this whole Magu thing, it has to expand somehow. Apart from that, we also need some parts around which just pop out, you know. And yeah, so let's do this then. Alright. So what we could do is that we could set up array right here. So array settings, raycast params new, array setting, filter type, filter, raycast filter type, blacklist, array settings, filter descendant instances. Let's see. Now, array, workspace, raycast. Let's see, x dot position, x position, x c frame, multiply with c frame dot new. Minus, let's do math huge 0. Let's put this inside of some brackets right here. Position 0 on. Oh. So I'm gonna be explaining this in a bit, do not worry. It didn't find anything. It didn't find anything, huh? It did not find anything either. Alright. Then let's actually cut this. Let's actually use something else, which is far easier to do. So I wanted to use raycasting to, you know, to find out which part was hit, okay? And according to that, I wanted to use that part's color for those shockwave parts, okay? But I don't really need to do it the way I've done it before, because so we do not need to use raycasting because I already have. Nah, I do not. I do not. I thought I was using this touched event. Nah, this is where things get a little bit interesting. Let's actually do something else. Let's only do it this way, alright? So I'm gonna create a part right here. Come on. So cast shadow false, break color, right. Oh, come on. Bright orange, where is it? There we go. Material is neon. And the C-frame equals our export C-frame. And it is anchored. And can collide as false. And we want this thing to expand, alright? So we are going to make use of the tween service. I've already explained the tween service in many of my videos, so go ahead and check out my channel and find a video in which I'm explaining this in detail. So tween info new, enum easing style linear, enum easing direction out, size is its current size multiplied by 30 and transparency 1, and we want to make this whole thing right here play. Alright, let's see how this looks like now. Now I forgot to change the shape of this thing to a ball, so shape ball, of course. Alright. Let's get rid of axe then, so axe destroy. And before we actually do that, we want to deal damage to all of those players who are nearby, so we want to loop through the workspace via get descendants. So get descendants basically gets everything inside of this workspace. So not only all of these, but also everything which is inside of there, and everything which is inside of those parts, and everything which is inside of those parts, you know, so on, so on. We want to check if the thing we're currently at is a model and has a humanoid, and whether that model's name does not equal our player's name. Alright, so those are the 3 requirements we want to have. Okay, so model implies that we have a character model, okay? And second requirement, so when there's a humanoid and when the instance is a model, we know that this is a character model for sure. And the third argument excludes the case that we have referred to our character's model. Okay, so next thing we want to check is the distance. So if v the humanoid root part position minus x position, so the distance in between both positions, the magnitude is not greater or equals, let's say 30. That is the case, then hit. Okay, and hit basically means humanoid, take damage, math random, let's say something in between 10 to 30. So a random amount in between 10 and 30. Come on, just load. Come on! I'm about to cuss badly, you know? I'm gonna pause it. I'm gonna be back when this thing decides to work. Alright, here we go. So it has decided to work. Okay. Problem is that there was no enemy nearby, therefore this wasn't a good test right here. So I'm just gonna move forward a little. I'm gonna spam this to be faster right here. Alright. Come on, let's try this out. Let's hope that this works. Ah, too far away. Too far away. Ah, come on. Impossible, impossible. There we go. So, Somewhere hit right here, as you can see, they have all received damage. Yeah, okay, so the hit thing does work. Last thing I would like to do is to create some kind of camera effect right here. So when script parent remote, now script remote on client event connect function. So remember, we have done this fire client right here. So when fire client, when this is done, we actually wanna make use of this tween service right here. Come on, where is it? Is it this? This is something else. Yeah, let's take this tween right here. Let's put the camera inside of it. So this is our camera, basically works based on current camera. And right here, we want to mess with field of view. So we want to increase this. And later on, we just want to decrease it back to 70 after 1 second right here. So let's see how this looks like. Didn't really work. Didn't really turn out as I've expected. Let's see. Now, where is it done? All right, here. Script parent remote fire client. Good, come on. So, why isn't this working then? Cam. So, if is cam, then end. What happens then? Still doesn't work. Oh, remote is not a valid member of. Oh my god, look. Oh. Your client scripts are so annoying. Look. Problem is that this local script right here loads faster than this remote. Means we're trying to refer to this remote before it even exists, okay? And that's something, or that's the reason why I overuse wait for child, you know? Because of things like this. It doesn't really make sense. It doesn't make sense at all. Look. Wait, is 70 really the default? Maybe should have tween for this as well. All right. So right here, let's actually delete those particles right here, which we have created up here. So let's just take this and let's set the transparency to 0 of the arm. Let's loop through the arm itself once more. And let's check whether the instance which is inside of it is a particle emitter. If that is the case, we want to destroy it, alright? Okay, that's just to that. Let's take this. Let's put it down here. And let's revert them. So let's revert the walk speed and the jump power. And then we are pretty much done. Okay, there we go. Now, last thing I would also like to do is I would like to add a weight right here. Because this fist right here appears too quickly, okay? Yeah, look. Come on. All right. Yeah, so this is basically it for this video. I'm honest with you, I'm still not really satisfied with how this attack turned out. So the particles are okay in my opinion. I really like that I've used this Bezier curve thing. Alright. So that this Bezier curve was at least helpful for you so that you have gotten a little bit more familiar with this concept of it. Okay, so I myself, I'm still new to this, alright, so I still have to study it a lot more. Yes, there is still a lot of stuff which I could have done better, but for the sake of this video and you guys not being videoless, I would still like to upload this product right here. With that being said, thank you guys for watching. Leave a like, subscribe, share this video to all your friends, leave me feedback in the comment section, guys. Take care and see you in the next video.